Hi, this is Kevi Zonyopinya. I am presenting on IoT-based home automation solution, an internship project provided by Emertxe Information Technologies, Private Limited, Bengaluru, Karnataka. Contents are hereby C++, IoT, embedded system, problem statement, project tools used, ADC and PWM, project requirements, Blink app, project integration, project demonstration, and conclusion. Here are the things I learned in C. It is a general-purpose language, a free-formatted language and not a strongly typed language. Keywords are of data types, modifiers, qualifiers, loops, jump, and more. Basic structure of C. Data representation, data conversion from decimal to binary, octal, hexadecimal, and vice versa. Conditional construct, if, switch, for, do while, and while. Operators, arithmetic, logical, relational, bitwise, language, and ternary. Over and underflow. Arrays. An array is a collection of data of the same type. Addresses are sequential. Pointers. Variable that stores the address of another variable are called pointers. Functions. A relation or expression involving one or more variables that perform specific service. Pass-by value and pass-by reference. Passing array and returning array. Recursive functions. Recursion is the process of repeating item in a self-similar way. Strings. Continuous sequence of characters are called strings. We've learned here the initialization, declaration, size, and library functions. Memory segments, text segments, data segments, heap and stack segments. Storage classes, preprocessor, header files, macro object like, macro arguments, macro multiple lines, macro standard predefined. IoT, the network of physical objects that contain embedded technology to communicate and interact with their internal states or the external environment is termed as Internet of Things. IoT allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for direct integration between physical world and computer-based systems and results in improved efficiency, accuracy, and economic benefit. Challenges in IoT and its solutions: addressing, pop and sock, scale, cloud, connectivity, queues, data volume, storage, cloud storage, device size, AMQP and MQTT. IoT architecture. The IoT architecture is divided into three parts: device connectivity, data processing analytics, and presentation. In device connectivity, there are devices which will send data to the cloud. These devices want to get connected to the internet in order to share the data to the cloud. IP-capable devices are those devices which are able to connect to the internet directly. Existing IoT devices, low-power devices, needs a gateway to get connected to the internet. Under data processing and analytics, there are cloud gateway and IoT solution backend. Cloud gateways collects data from different devices, puts data in standard format. Whereas, this IoT solution backend is where the processing and analytics is done. Presentation. Mobile application comes to pictures here. Embedded systems. Any combination of hardware and software which is intended to do a specific task can be called as embedded system. Resources can be implemented on a single IC, include a variety of peripherals like timers, analog to digital converters, digital to analog converters, and serial interfaces. Small size makes them very versatile. Now, here comes the problem statement. The problem statement of the project is that to control home devices using Blink IoT app through Blink Cloud Server. Project tools used. Software: Arduino IDE, FiximLab Emulator, Null Emulator, also called Setup, Blink IoT application. Hardware: LDR sensor, LED, PLCD, Arduino Uno Atmega 3280, Ethernet shield, temperature system, and water tank. ADC and PWM. ADC stands for Analog to Digital Conversion. Analog signal is converted into digital signal with the help of ADC, and the output will be pulsed with modulation signal. Steps are sampling, quantization, and encoding. Pulse width modulation is a method of reducing the average delivered by an electrical signal by effectively chopping it up into discrete parts. The average value of voltage fed to the load is controlled by turning the switch between supply and load on and off at a fast rate. Formula used is step size is equal to input range divided by 2 raised to resolution. The project requirements are 1. Garden lights control. The garden lights are controlled based on LDR sensor. Here, during the daytime, lights will be off, and during nighttime, lights will be turned on. 2. Temperature system control. Temperature system is controlled by using Blink IoT application. Through the Blink app, you can turn on and off the heater and cooler, and respective notification is also sent to the Blink app. Here, if the heater is on and the temperature rises above 35 degrees Celsius, the notification is sent to the mobile app, and heater is turned off automatically. 3. Water tank control. Here, the tank inlet and outlet valve is controlled using button widgets on the Blink app. When the volume of the water in the tank is less than 2000 liters, then a notification is sent to the app mentioning the status of the tank, and the inlet valve is turned on automatically. Once the volume of the water reaches 3000 liters, another notification is sent to the Blink with the message, "Water level is full," turning off the inlet valve. Then the inlet valve is turned off automatically. Blink app. To use Blink application, we need to install Blink application in our mobile device. But before using this Blink application, we need to create a Blink account in Blink console website. After creating our Blink account, we create template as home automation, and then add new device from the templates. We save the template ID, device name, and authentication token to a text document for further use in the coding part. And then we add data streams. These data streams are virtual pins. We give them each names and virtual pin number to each of the data streams. Then, from Blink mobile application, we build required widget buttons. Project integration. Arduino IDE. We install the required library files like spi.h, ethernet.h, Blink simple ethernet.h by going to the Tool tab and clicking on Manage Library Files. We code, then save and compile. After this, if there is no error, we go to export the compiled binary by going to the Sketch tab. Then we load the hex file in the FiximLab simulator. FiximLab simulator. So this is the screenshot of FiximLab simulator. Here we see the spare parts and the cereal tank that we need for the project. Now I will be showing the project demo. This is Arduino IDE, where the coding part is done. So this is FiximLab. To get the spare parts, we go to Modules and Spare Parts. Now, in these spare parts, we have LCD, then this is temperature system, LRD to detect the sunlight, and this is LED. Here in Tools, we get the serial remote tank. It will take some time. So this is the serial remote tank. To connect this with the PICSIM lab, we need to see the COM port, which is a null emulator. Here, since this is COM2, we take here as COM1 for the pair, and we connect it. Now with the Miro app, where is the Miro app? Here, this is the Blink app. We have tab 1 and tab 2. Tab 1 for controlling the temperature system and tab 2 for controlling the serial tank. Here, this is the serial tank. If we turn off the outlet valve, the volume of water will decrease. And once the volume of water reaches 2000 ml, 2000 liter, the inlet valve will turn on automatically and the message will be sent here, notification, which says water level is less than 2000 liters, water inflow enabled. So it's enabled automatically. We can off the outlet valve here and the volume of water will increase. Now, if we turn on the outlet valve here, we can see the notification on the PLCD that outflow is turned off. And when it becomes less than 2000 ml, 2000 liter, then here the inflow is turned on automatically. You can turn off, here off, and on and on. You can turn off the inlet valve, here saying inlet inflow on and inflow off. Now in tab 1, we have the temperature system controlling part. We can control the temperature system here, where when we turn on the cooler, the fan starts running, and here the notification on LCD says cooler on. We can turn off the cooler and cooler off. This one stops. Now when we turn on the heater, it says heater on and the temperature raises. Once the temperature reaches 35 degrees Celsius, here we get the notification in a Blink app saying temperature is above 35 degrees Celsius, turning off the heater. So the heater is turned off automatically. Now coming to the garden lights, this is LDR, the light sensor, and this is LED. When the resistor is high, the LED light is on, which means it is during nighttime. Now when the resistor is low, it means it is during daytime and the LED is turned off. LED light is turned off. So by this we can say that the garden lights is controlled. Lastly, conclusion. In this project, we are able to use Arduino IDE and code in C++. We are able to use PICSIM Lab emulator and Ethernet shield. Then we learned how to use Blink IoT application and the Blink console website. We understood the idea on how to make career in IoT field. Then we understood about IoT, embedded system, microcontrollers, and different memories. We understood the working of Arduino where LDR sensor is used, LED, temperature sensor, and serial tank are used. Thank you.